Hi, this is Nick, and I'm with Atlantic Laser Scanning Services. Today, we're going to take a look at registering data using the FARO SCENE software. The version is 2022.1.0. This is going to be a really simple project. This data was collected with a FARO Focus X330, so the scans are not assembled at all in the head of the scanner. This is all done in the SCENE software automatically. So for those of you who are concerned with using a S series of 150 or 350 as opposed to one of the X series units like X330, we're going to just take a look at what this software is going to be doing with the data from the older X330 units, and if it's really something to be concerned with. So real simple, when you pull the SD card from the X330 scanner, you're going to put it into your laptop with the SCENE software loaded on it, and this is the screen that's going to come up. So whatever name you gave the project in the scanner, obviously you can see is the project's name when you pull it up. So this is, again, a building facade scan. There are no targets used, so we are not going to go into pre-processing, and we are going to go directly into registration. Now, you've got a default registration method that FARO uses when there are no targets that are used. So we're going to look at that real quick. This is our opening screen. You can see the different types of registration options up here. Then you've got also an option to use the registration, basically the same thing as auto registration up here in the left-hand corner. So we'll just grab it here, start automatic registration. Now this screen is going to open up, and it's got some important information. We are not going to alter any of the information that we are scrolling down to look at, but what I want you to look at here is the selection options for registration. So it's defaulting at what's called top-down and cloud-to-cloud. If you pull that menu down, you're going to see target-based, top view-based, cloud-to-cloud, and then the default. So why are we set on top view and cloud-to-cloud for the default registration method? What FARO does is it's going to take the scans, say scan 1 and scan 2, and if you are in an area, hopefully, that has geometry. So if you're going to be, in this case, scanning the side of a building, any interior or exterior of a building or a piece of equipment that is stationary, when you work the scanner around it, there are going to be geometry. There are going to be corners in geometry of that piece of equipment or that building that are stationary, and that they're going to be used for registration points by the software. So in other words, they're going to take scans 1 and scan 2. It's going to do a top view first, meaning it's going to look down onto the scans and rotate them next to each other, looking for common corners, whether it's equipment corners, building corners, interior, it might be furniture, that might be other equipment, but it's going to rotate them until, like a puzzle pieces will fit together. They'll just lock them together that way. Once they do that with 1 and 2, then to 3 and 4, and 4 and 5, and so on. That will then roughly put the scans together. And then cloud to cloud is the secondary method they're going to use. So once it's basically stuck together with top down, it's going to look for X, Y, Z points in space. And once it does this, it's going to sort of lock those scans together in an even tighter registration. So that's why they use a default of top view and cloud to cloud registration. As I said, everything else can stay the same for what we're doing, and then we're going to register and verify. Now we've got a finished registration. This is the screen that's going to pop up next. It took about 8 minutes from the time that we began the registration to the time that it finished. So we're going to allow that to load the points for each scan. It's going to load in a format. We're going to see a different color for each of the scans. We're going to see their position. So based on the fact that this is in a nice grid pattern in front of the building, it looks as though it's going to be coming through fine, but we'll let that load up. This type of view is also going to show how much overlap that we've got between the scans. So, you get a X330 unit and it has 330 meters of range. That first 80 feet or so of range is where you get the 1 to 5 millimeters in accuracy, 2 to 5, 1 to 4, depending on the machine that you're using into the S series. And so that means that, if you're scanning down the side of a building, just because you get 330 meters of range, you don't scan on one side of the building and then go 300 meters to the other side and scan again. You're going to need to step that scanner through that sort of distance because, again, you've got the first 80 feet is where the accuracy is. So let's just say you scan every 100 feet. You've got an overlap at the 50-foot mark. That should keep those two scans within that 2 to 5 millimeter accuracy for an X330. A lot of times 70 feet, if you're wide open like that, is going to be more than okay. So anyway, here we go. We've got what looks to be a very good registration. We can just say yes and finish. We're going to return to the dashboard and jump into Explore. You can see it has tried to load the 3D view, but we have to actually load the scans prior to doing that. So here you see we've got a scan manager. It's got a green light. We can double click on that if we'd like. We can see our scan results, our scan fit, and the tensions. We've got an average of, say, a little over 4 millimeters. That's very good for an outdoor scan like this. So to take a look at what this is in a 3D view, we're going to go to a correspondence view. Again, this is going to be a view where the each scan is a different color, and we're going to get a chance to see what the scan looks like at a few different angles here. We can drop a center point really anywhere, and there you go. Nice hard line on the front of the building. Easy scan project. We can look at this completely differently. This can be just a regular standard 3D view. This is not going to show us our individual scans. This is just the project, everything that was captured. You get a lot of people that want to know when they first start using a 3D scanner, well, hey, it's, like I said, it has 330 meters of distance capture for the X330, for instance, or 350 with the S350. Is that going to be data that I can use? Again, it really isn't. You want that accuracy, that 2 to 5 or 1 to 4 millimeter accuracy, depending on the scanner type, because outside of that, let's just take a look here at this building, for instance. We've got data captured on the building on the far right. Now that building might be 250 meters away, and we look like we've got pretty good coverage, but as we come in, you can see that the actual data points are much less saturated than what we've got from the building that we actually scanned. As you see, we get closer, we've got a lot of thickness to that point cloud. And that means that when you are looking at something that is a long way away, you did get laser scan points to make contact with that building. But as they go away from the scanner, and we can look at the correspondence view to get an idea of where that scan was. Let's just say up here's the building. Down here, you're looking at scans 5 and 6. This scan distance, let's just say it's 250 meters, meaning by the time it gets to this building, the scans are now spreading apart as they're going away from the scanner. So the scan points left to right, let's just say, on the building itself, they may be 5 or 6 inches apart. So you're not going to get good accuracy when you're looking at something that's that far away. If you simply want to know, hey, how far away is that building from my scan location? That's a different story. That will give you a distance that's accurate. But if you're looking for any kind of detail on the side of that building that you captured 250 meters away, uh, it's not enough scan points to give you the sort of left to right or depth detail that you really would need to say, fit a window or do anything that you would want to trust with your customer. So anyway, that is the scan project. Now, one more thing, um, and this is something that a lot of times beginners will run into uh, on a pretty regular basis, especially if you send a scan tech out and you want them to scan something like this for you. Let's just take a look directly from the top. Now, there are going to be times where projects don't register correctly, and you wonder why. And what that happens is, let's just say around this corner where the cursor is sitting, this is going to be where you want to scan. You want to pick up this other side of the building. Now, you can't scan a scan position number 4 and then immediately go way down here and scan your 5th position. Why? Because the scan registration software needs to clearly see the geometry from the previous scan location at the next scan location to be able to fit them together. So by running all the way down the side of the building and scanning, the computer can't stand at this location where the cursor is and see anything from where scan number 4 is. All scan number 4 saw was this front of the building here with the trees. You can't just run around a corner and scan over here to your next scan and not have any view of the previous wall where the trees are here. So in other words, when you tell your new people to go out and perform a scan, the best thing that they can do to go around a corner, inside, outside, when scanning a piece of equipment, when scanning a car or a truck, is you want to scan on the corner section of whatever you're trying to scan, because you're then picking up everything along the front of this building here where the trees are, and you're picking up the side here that's purple. That's where you're going with your next couple of scans. You're working your way around the corner. Make sure you get that corner scan. Otherwise, you're going to end up with, a project where the front came together and then the side is in a different cluster and it's off in space someplace, way over here on your screen, and you're going to, have to work to try to put the two scans together. That takes a lot of time. It is better to make an extra scan in the field, not cheat by going too far between scans. It's better to spend a few extra minutes in the field than to try to cheat and then fix it once you come back to the office, fly home, and then try to put the scans back together. So listen, good luck, you guys. I know this was a basic sort of video. I hope it helped you out. Please, you can email us at info@atlanticlaserscanning.com if you have any questions. Again, we rent FARO scanners. We also have the Creaform HandyScan Black Elite scanners. So we're a comprehensive 3D scanner rental provider, and we do a lot of education work and answer a lot of questions for people. So again, thank you and good luck with your next project.